Let's go. Good morning, good afternoon, good evening, good dawn, good wherever you find yourself. Welcome to IoT Tuesday. It's the only show that demystifies AIoT, which means artificial intelligence and Internet of Things, trying to demystify it to the barest minimum so that you can understand, appreciate it, make things, break things, and have some fun. We're back again with episode 71. In today's session, we're going to do an unwrapping because it's not in a box. All right, I've taken it out of a box, so we'll be doing an unwrapping of a new module or a new kit I got from Seed Studio. Yeah, we'll be taking a look at it, getting started, how to set it up, and then also I would be taking you back a bit from last week's session, just to share with you what was causing the issue we had in the latter part of the show and how I fixed it and how it worked. We will come back again to do a series of stuff. And the reason why I'm unboxing all the XIAO modules is they pretty much follow a similar pattern. So once I unbox all the XIAO modules, we can look at how to use the Bluetooth, the 6-axis, all that on it, and other, NFCs and all that. So today, if this sounds like something that's of interest to you, please subscribe to the channel. Before we get started, let's go for our montage and then we'll get right into it. Yeah, we're back. Sorry, once again, welcome to you all joining from Facebook, Twitter, YouTube, LinkedIn, Twitch. All of you, welcome to the show. You can say hi in your comment sections on any of these platforms, and I'll acknowledge you and say, just give you a shout out, and then you can drop your questions as well. So, as you know it, before I get started every time, I have a bunch of information. Sorry. I have a bunch of information I try to give you regarding IoT before we get started on the show. And today I have, hey, Kissy, welcome to the show, Kissy. Welcome. You still owe me an appearance, all right? So this is a schoolmate of mine from high school, and he is into all the industrial IoT stuff, so all the SCADA, PCLs, all that. And I need to grab him so that he comes to share some industrial IoT stuff. And so please, Kissy, this one I've said it on the show. If you don't come, the viewers will come and attack me. So let's put something together. But thank you for patronizing. Thank you for joining again, so we can learn something. So I'm going to give some information. I'm going to start in a bit of a sad news. I don't know what I'm not going into the details of what why this is, but if you've been using how do we call it, the Google Cloud IoT Core Managed Services. Thank you, Kizzy. So if you've been using the Google Cloud, right, IoT Core Managed Services, the sad news is that Google is sunsetting it a year from today. Today's 16th August, right? So yeah, so 16th August 2023, Google is sunsetting it. So which means that you will not be able to access your IoT services. You can't use the APIs. You can't use any of the services provided by the Google Cloud IoT Core Managed Service. You can't use any of them. Now, this means from now till next year, exactly a year from now, you need to figure out or transition or move or migrate your workload from that platform to other platforms, right? Thankfully, my friends at Quibutro have put together some guide on how to migrate your stuff, your workload from the Google Cloud IoT Managed Services to the Quibutro Cloud, all right? And I would share that in a bit right here so that you can see that. Give me a sec, people. Let me load this up and share it with you. Let's open this. So yeah, that's the that is the sad news. That is a sad news. So yeah, so let me put this here and let me share this with you. So on your screens right now, it's the URL or the resource to the Quibutro migration guide, how to migrate from the Google IoT core to Quibutro, right? And I have a scheduled Quibutro session coming out, I think sometime next week or so. So I'm gonna walk you through how to get your devices stuff into Quibutro. My good friend, fellow ambassador, Samuel has done a lot of introductory videos on that. I also shared that in the link in the description, so you can go check that out. But I'll be doing more intermediate to advanced stuff because he's already taking time to do that, so I don't need to reinvent the wheel. So that's the first one. Now, I would try to follow up with how to also do the migration from Google Cloud Platform to Azure, Microsoft Azure. So all the Azure IoT services, I'll show how to migrate your services from Google to that, and then we'll do some AWS as well. So that's the sad news, all right. But hey, it just means you have to evolve. Now, the next thing I want to share is good news. So from the bad news, it goes to good news. So starting in September, we're launching or starting the Accra AIoT and DIY user group. Yes, it's exciting. This is in partnership with Kubutro, with Afrilogic Solutions, with Design Logic Maker Hub, Hackstar Accra, and then we're trying to get some goodies from C Studio as well and Arduino. So if you're someone who is interested in practical AIoT, hands-on AIoT, and do it yourself, please make sure to join that family. Let me also drop the URL to. We have a Google form we're using. So yeah, there you go. So that's the forms as well. Go check that out. Fill the form. Let's know what you think and join us. We're going to start with the first virtual session, and then we'll transition into a series of in-person hands-on workshops and getting to learn Quibutro, Arduino, IoT, AI, and all the crazy stuff, right? So that's all I have for news, all right, or for updates. That's all I have for updates. So let's get into today's show. So last week, like I said, we saw the getting started with the C Studio XIAO BLE Sense. We saw how to connect it, Arduino, do the very, very basic blink and stuff like that. Today, we have something different, right? But before we get into it, there was a simple, well, I won't say simple, but there was a problem when we're trying to connect an external temperature and humidity sensor to the XIAO BLE Sense. And that was because I later found out after the show that I was having conflicting libraries. So it wasn't sure which of the libraries to pick. So I had to go and remove all the libraries and reinstall them, and then boom, it worked. So let's go to the bench, I'll reconnect it, and I'll share a couple of findings with you. I hope, yeah, for some reason I keep getting, our stream keeps dropping. I don't know if it's the bandwidth or something, but let's do this. Let me, let's bring this here. All right, let's go to our browser. There you go. There you go. We don't want this, so let's go here. Yeah, let's jump to the browser. There we go. So let me go to this. This is what we'll be doing today, but there are a couple of things that I want you to pay attention to, especially when you're connecting or making use of the Seed Studio Groove connectors. All right, there's some very important stuff you need to look out for. So let me do humidity sensor. Let me just search for this. And yeah, and don't forget, if you have any questions, just feel free to drop it in there. I just want to be sure we have the same thing. Which one is it? So temperature, humidity sensor, 4 ping. So it's pretty much the similar thing here we have. So this one. Okay. So now in connecting this, right? In connecting this sensor. So if you look at it closely, you have the VCC, you have the signal, the NC and the ground, all right? Then if you look at the port connections here, let's see if we have, let me change to another view. Let's see what view we have here. Okay, so temperature humidity sensor version 1.2. I'm not sure if it is the let me see. I want to be sure. Yes, DHT11. It's DHT11. Okay, so it's not this. Let's see if it's DHT22. It might be DHT22. Hold on. No. It's DHT11. All right. Oh, a DHT20. Okay, so it says since DHT. Okay, so this is it. DHT11. So this one. Let's go up here. All right. So if you look at the schematic, so you have ground, you have the VCC, and then NC and signal. Now, when you look at the connection on the JTAG cable, right? So your your ground is the black cable, all right? Your VCC or the power is the red red ribbon cable, all right? Now, when you connect it, then the signal is the yellow cable. All right, the signal becomes a yellow cable. Let's go to the bench. Let me illustrate this properly. Yeah. And yeah, this tells you that I just jumped from a work meeting and then I came live, so I didn't set the bench camera very well. I need to try to make the bench camera a bit stable. So let's just move this here. I just want to illustrate something. So I'm going to hold it this way. All right. There you go. So if you look at the ribbon colors, right, you can see the signal is the yellow, right? The yellow one. Now, let's come back quickly. Okay, let's come back quickly to the documentation because I want to show you something. So let's go here. Because at some point I wasn't getting the actual value, and I knew that I had to put it on the groove JTAG pin 2, but I wasn't getting what I wanted. So let's see. Where is that? There was something that I wanted to show. Let's look at this. Groove temperature. Okay, let's look at let's look at the wiki. Let's go to the wiki for this one. All right. I think it's in the wiki. And it's just something I want to point out so that you don't make the same mistakes when you're connected. Sometimes if you think you've connected stuff but it's not working, you be cautious of it. All right. So yeah, so this is what we have. Won't go about the features, and there you go. So the key specification, the interface, and all that. Good. So this, let me bring it in so you see this. So this is something you need to pay attention to when you're using a lot of the Seed Studio. If you're using the Seed Wiki and the Seed documentation, all right. So if you look at, it tells you that red 5 volt, black is to ground, the white is not used for anything, but the D2 digital pin D2 that you want to use, that is where the yellow pin should be. That is where the yellow pin should be. And then you need to download the Seed DHT library, right? So I think I had one for Arduino, DHT Arduino library, and some other ones. So it was conflicting. So I had to remove everything and redo it again. Now, so this here, when I say D2 has to be the yellow cable. Now let's go back to the bench, and then I can properly illustrate and explain this to you. so you don't make the same mistakes. All right. So if we take, let me remove this for now. Okay. If we take our extender, okay, our XIAO extender, let me turn it this way so we can see where this is. There you go. Okay, so let me see if I can get, and forgive me, I'll try as much as possible to get this very, very, very close. All right. So, and what I want you to pay attention to is this here. This two, right? This and this one. Now, let's see if I can stabilize this a bit. Come on, come on. That is why I need a camera that can do this autofocus without a lot of hassle. Oh no, come on. Sorry guys. I probably will have to pull the focus manually. Anyway, well, what I want you to look at, well, or to be mindful of, is that if you look here, these are the two pins, right? And so they have ground voltage 1 and 2. So if I connect, so take a look at this. If I were to connect the cable this way, right, because that's the way it's going to go in. If I connect it this way and I start to read it, I see black is to ground, red is to 3.3 volts, don't worry, and then 1 is to white, and then 0 is to yellow. But that's not what I want. But then if I move it to the next one, you see that I have the ground, the 3, and then the white is 2, right? And the yellow is 1, right? So it means that I can use it. I move it to the next one here, the third one here, and then I see that there's ground. I see ground, the voltage, the yellow is, the white is pin 3, and then here the yellow is pin 2, all right? So this tells me that I need to use the third groove slot here for it to function based on, how do you call it? So based off of the pin I have defined to use in the Arduino sketch, all right? So that's something that was also a factor in not making the code run, and I was just hitting my head against the wall and stuff like that. Okay, so now let's connect this, and then also, for some reason, I probably had my laptop running or on for quite a number of days, so I had to also restart it for it to release the COM port that was being used, because after a while it couldn't tell me that it was connected to a specific COM port. So that's just something to be mindful of. So I'm going to show you, and we'll see if we can replicate the same thing also on the ESP32. But we've not come to we've not unboxed it yet, so, or unwrap it yet. So I'll come back to that. But the principles and the concept is still the same. Like I said, I want to do all the unwrapping or unboxing, and then we can now dive into the ESP32, which is being able to use Wi-Fi and connect it to the internet, and then I'll share some use cases for us to check out. Okay, so I'm just connecting my USB extension cable, all right, which is this one, so that I can connect this to it. So before we do that, let's go back. Let's go back to the screen. Let's go back to the desktop. So I show you. And yeah, don't worry, if you have any questions, please feel free and drop the questions in the comment section so I can answer that for you. Let's see. Let's do this. And yeah, we've not yet unwrapped it. We've not yet unwrapped the ESP32 version, but I just wanted to throw you. Okay, so this is it. Let me walk you through the code. Let's walk you through the code. So pretty much quite simple. We're bringing in the DHT library, like I mentioned. we're defining the pin, which is what? DHT pin 2. And then we are defining the type, the DHT type, all right? So that's going to determine, how do you call it? It's going to determine how it's going to read the value. It's going to use the Y. It's not, I think it's not, how do you call it? This is able to read the temperature and humidity over the wire. So, and then now we're setting the DHT, right, which is our instance of the DHT sensor, to use pin 2 and set the type to DHT type 22, right? So let's go and then set up. Obviously, we are opening the serial monitor at this baud rate because it's quite fast. So we're doing the test. We begin and then we start reading it. And then what we do is, let's go here. Nothing fancy, all right? So we're just setting a flow array object or list, and then we are reading, right? If there is a reading, we are just printing the humidity, the value of the humidity, the temperature, and the value of the temperature, because it comes in an array or list form, right? If we can't do a reading, we just say fail to read it. So this was just the basic stuff. And then obviously, as you know, before you connect it, make sure you've selected the right board and you've selected the right COM port, right? And for me, it says Arduino update for Arduino. So I always use, if you're on Windows, I always use my device manager. I open my device manager just to be sure that I can. So if you look at the COM port, as of now, COM 3, 4, 5 are occupied. So I just use this so that when I connect, there you go. So as soon as I connect so I know that is COM port 11. So if you take a look at this, COM port 11 has been added to it, and that is where the XIAO is. So if you go to the board, you see that there's a light that shows you it's running. So I've already deployed this sketch on it. So let's go to tools and open the serial monitor, and let's go back here. Let's try to do, let me take you to, and you can see it's reading the temperature and humidity. Now this is quite out of, I have to fine tune it and make sure I'm getting the right temperature. But at some point I want to believe it's also part of the type. So you know what? So let's close this and let's go back to, so there you go. So this is telling us that, let's see, this is DHT11, right? So I think it is fair. We go back to the sketch and then let's do DHT11. Okay, save this. And I'll try to redeploy this on the board. So that's going. Let's open this up. And if you want to know how we set this up, we've already done this in the previous episode. So we'll try to drop it somewhere on the screen for you to go check out. So hurry up, deploy that, deploy that, deploy that. So once this is done, we'll run this again. And as you can see, now we've been able to connect an external temperature humidity sensor to our XIAO, and it's working fine. It's reading temperature, humidity, and then you can use that to do a lot of things. I think I showed you a bunch of groove sensors you can use to connect to it. So pretty much go crazy. If you have any of the sensors, the external groove sensors, you can connect it to it. There is a groove kit, starter kit specifically for the XIAOs. There's the extension, as you can see, and then there's some other boards. But this is just to make our lives very, very easy. So we're just waiting for this to deploy onto it. And then we will run there you go. So deployed, upgrading the target package. So I think this somehow changes the port. So let's see, did it close my, okay. So device is programmed. There you go. So let me see if, again, don't worry, it's just a matter of, okay, so I think it's running. So let's try this again. Let's go to tool, serial monitor. There you go. Now you see. So you see that by using the correct the temperature humidity sensor type we are getting more accurate data. So you see that humidity is 77%, temperature is 24 degrees. So let me go to the split view, and I'm going to try to blow some air. I don't know if you can look at, if you look at the top left, yes, top left, no, yeah, top left, here, even though I'm using my right, but if you can see the value. So I'm going to try to blow some warm air on the sensor, and then we'll see the values, right? The values change. Yeah, and you can see that we moved from 24 to 28 because I blew some warm air onto the sensor. Now it's 29, 28 is coming down, 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 down. All right. Yep. So that is the things to take a look at, okay, when you're connecting it. And I think because I'm going to use the same extender, I will leave it on the same port. And then when we finish unboxing or unwrapping the ESP32 version of it, you know, we can have some fun. So now let's go back to the bench, and let's keep this here. We can leave this here. So are you ready? So now to the main event. We're going to unbox the ESP32 version of the Seed XIAO board. Let me bring here. There you go. Da 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 da. Let's open this up, and then I can share a few things about it. So it's pretty much, how would you say it? So let's do this. Let me bring this here. I just want to open the specification, and then we'll see how it compares to the other, you know, the other seed boards. Okay, the other XIAO boards. So let's open this up, and then there you go. The MCUs are here, and yeah, if you have any questions on this might seem a bit trivia, but that's how, you know, that's how complex IoT systems are. It's just small bits and pieces of it. You know, you start with you start with a small concept and you grow it out. All right, so there we go. So on the C Studio site, come on. Yeah, I loaded it, but I think I went back. Yeah, so the MCUs, right? Microcontroller unit. So here, this is the XIAO ESP32. As of now, the retail price on Seed Studio is $499. Yeah, it's $499. As you can see, so it's a ESP32C3 tiny MCU board. It has Wi-Fi, it has BLE, it has the battery charging support. So which means that so for most of the XIAO, all the XIAO MCUs, you can actually use a battery charging component. So you solder that behind it, and it can run on one of those lithium batteries. And the form factor is what makes it interesting. So which means that, you know, you can technically use this to create a lot of applications that require, you know, a small form factor, right? That requires you to have a small form factor of things. Oh yeah, you know, that requires a very small form factor. And the fact that this speaks Wi-Fi, that means that you can connect it to the internet. So this can be your in the field kind of like gateway, inexpensive, that takes data onto, let's say, Azure IoT Central, Azure IoT Hub, Kubutro, and all the platforms. And that's what I'll be focusing on. So I will be looking at, you know, coming from device to, let's say, some form of a processing, and then sending that to the cloud, not just directly. All right. So yeah, so these are just the fundamental features of it. Let's go here. So you can see, you can, you know, obviously if you've used ESP32 before, you can understand that it's more powerful. So you have a tiny MCU, more powerful than your, you know, your regular Arduino that you started with, that allows you to have, you know, create very powerful, you know, powerful solutions. It has an antenna provided. Did it come with? Yeah, so it has an antenna. Don't worry, we're going to open it, so don't stress. Don't stress it. Its thumb size, as I've said with the other versions, has a low power consumption, 44 microamps. You can put it in deep sleep mode. Onboard battery IC, so it allows you to do the battery charging and all that, and it's ready for production. So it means that you can pick this XIAO very small XIAO module and build your circuit or your production out and just drop it onto it, and your applications are running. All right. So ESP32 chip. So these are some of the use cases, but I wanted to share some of the few scenarios with you. Okay. Let's look at the specifications, and I'll share some few scenarios with you. So the processor is an ESP32C3 SoC. You have the Ryzen V single core 32 processor chip with 4-stage pipeline that you can go up to 160 megahertz. All right. Has 2.4 gigahertz Wi-Fi, has Bluetooth 5, also supports a mesh, which means if you deploy multiple of these things, they can form a Bluetooth mesh and work with it. On chip memory, you have 400 kilobytes SRAM and then 4 megabyte flash. Interfaces, there's one UART, one I2C, one I2S, one SPI, 11 GPIO and pulse width modulator pins, and then you have 4 ADC analog to digital converters. The interface, as we see, has one reset button, one button, dimension quite small, thumb size. Power can work on the 3.3 volt at 200 milliamps. So that's why this XIAO can power it effectively. Charging, you require 50 milliamps. And then input voltage, you can put a maximum of 5 volts. Don't go beyond that, you fry it. So deep sleep power consumption, less than 44 microamps. Wi-Fi enabled power consumption, yes, so you can see all that. So the application, so this is what I wanted to share with you. So let's go. Where is that? Yeah. So some of the interesting use cases that I found, which we could leverage the XIAOs to do. An interesting one is this. No, let me open this in picture. I don't know why. Open with choose more app. Not paint. Picture viewer. Okay, let me actually yeah, photos. Let's open this up. And then once we have this open, I think we can drop this here. Right. Let's close this. Let's open with no. Where is our photos? Okay. Choose from my PC. Yeah, I need to choose from my PC. Okay, no problem. Let's open this up here. It's just to share that up. All right, so this is one interesting use case here. So you see this smart private garage solution where they have two modules, one on the car, which is a smart key, and then one on the door, which is a door controller. So you have, they're very tiny for you to create processes like this. So because it has Bluetooth and you can have accelerometer, you can add a bunch of things to it easy. I can have one with the car. As the car is approaching the gate, you can now signal it, whether it's by Wi-Fi or Bluetooth, however you want to do it, signal the door controller to open the garage door. This is one interesting example. The other example here is also for a remote forest tracker. And this is quite interesting for me because the Into the Wild challenge, there are some challenge we want to address. For instance, animal tracking or color or camera traps and stuff like that. Because of the small factor of the XIAO, you can also do you can set up some of these things, right? So as you can see, you can use the Groove GPS module connected with a LoRa for long distance, and that can communicate via what, using the XIAO ESP32, because that has Wi-Fi that can now push the data to the cloud. All right. So let's take a quick look at let's go back and now take a quick look at, you know, the layout. Okay, so let's open this just like we do. So if you look closely, pretty much resembles the same stuff we have. We have the 5 volts ground, 3.5 digital pins, 10, 9, 8, 7 GPIO. So you can see you have almost the same form factor, right? Now if we go to the so this is the front, the back part of it. You see the terminal part. You see here the battery connector, so you can solder stuff here and connect the battery for it. You have the JTAG parts, and then the GPIOs. Let's look at, so the front side, you have your Type C interface, your charge LED, your ESP32C module, which is the big one here, your boot button, your reset button, and then you have your Wi-Fi Bluetooth antenna connector, which you can put on it. All right. So that's just everything about, you know, about it. But now let's go to the bench and let's go and do the cool unboxing. I'm going to move this here for now. Let's push this here for now for it to work. So I got myself, yeah, I got myself 10 pieces. It's like, wow, that's exact. Yeah, 10 pieces, because I have a lot of crazy concepts I want to try with this. So it came in the box, and I think I tweeted about it. So yeah, I might give a few out to, you know, loyal followers and viewers of the show, because I have, you know, quite a number here. And maybe in the days coming up, I'll probably order more, just to finish the projects. And again, so these are things, if you're interested in playing with some of these things, make sure to join the, you know, the AIoT and DI user group, and then you have a lot of fun. All right, let's do this here. So we'll just take one package. And where is my bench knife? Careful with knives and all these things. All right, so there we go. I'll probably cut it from here. Awesome. What do we have here? There you go. And yep, we can put all the rest back. Today we need to do one. Yeah, and I have quite a number of them, because if you want to do, let's say, Bluetooth to Bluetooth device communication, you need more than one. So bear with me. All right, sorry for that shake. So this is it. This is how small it is. The same form factor. All right. And then, but wait a minute, they didn't add headers to it. Seed Studio. Okay, maybe I might have ordered this one without the pins, but anyway, I have a bunch of those pins, so I can easily create them. So as you can see, this here, the Wi-Fi and Bluetooth antenna, right here, I can easily just fix it here. All right. I'm just trying to fix it right here. Okay, in the middle here. So let me do, sorry, I have to take it off screen. Is it connected? Wow, I think this is where I need my magnifying. Yeah, so hold on, guys. I think this is where I'll need my, let's see. And is it connected? Yes. Oh, finally. Yeah. So there you go. This is it. All right, let me bring this here so you can see it. There you go. And then the antenna is here. All right. So with this, now, so yeah, I have a bunch of, yeah, I said I wasn't going to do advert for Big Jim, and I keep bringing his box into my view. Anyway, so so here I have a bunch of group sensors, LoRa, stuff that we can use, but we're still going to stick to the temperature and humidity one. I want to see if I can have another one, or you know what? We'll just use the same one. Okay, we'll just use the same one. So, in terms of connecting it, I'll take this one out. We're still going to use the extension board. All right, we're going to use the extension board. So, I'm going to gently take it. Take this one off. All right, there you go. And then I'm going to put this here. So this has already been programmed to run temperature, humidity. So yep, connect this. There you go. So now what we have here is the XIAO ESP32C3 on our extender, right? And it's the same thing, the same pin. So there you go, right there. Okay, so let's put this here for now. And so let's go ahead and set it up before we come and power it and do some fun stuff to it. Okay, yeah, I think we have enough time to do this. It would obviously be a similar way of doing how do you call it? It's going to be a similar way of setting up the XIAO, but there are a few things we need to walk through. So let's bring this out. Now, good. Before we do that, let's actually put it in perspective, because we've unwrapped all the XIAO modules. Now, let's look at this. Oh man, sorry. So this here is supposed to be some comparison, all right, between all the boards. So far you've seen me use the Sense, which is almost like the BLE. We've used a XIAO on its own. I don't think we've used this XIAO RP240. I don't think we've used this, but you've seen me unbox this. We've unboxed this. I think this was the first one. This was the second and third. And then today we are unwrapping this one. Okay. Now, with all these, in terms of processor, take a look at this. ESP32C3, so 32 bits. This one uses the M0 Plus 48 megahertz. This is 160 megahertz. This is using the NRF528 Nordic Semiconductor. So this two. So BLE and BLE Sense on the same, technically using the same processor. Then in terms of wireless communication, ESP32 version has Wi-Fi and Bluetooth 5, low energy, right? The XIAO on its own and the RP2040 doesn't have any wireless connectivity, but the XIAO BLE and XIAO BLE Sense all have Bluetooth 5, Bluetooth low energy, and NFC, right? So pretty much just two are the same. Then in terms of memory, right, the ESP32 has 400K SRAM and then 4 megabyte onboard flash RAM. You can see compared to it, 256, 1 meg, 2 meg. So in all of its entirety, it's, in terms of processing power, connectivity, and memory, the ESP32 version has a lot more. Now, the downside to it, well, I won't probably say the downside to it, all right, is, let's come here and then talk of built-in sensors. Okay, let's talk of built-in sensors. In terms of built-in sensors, the ESP32 doesn't have any. All the other ones don't have, with exception of the BLE Sense. So that's the difference between the BLE and the BLE Sense. All right, the BLE Sense has onboard or built-in sensors. The 6, axis. You have the microphone, all right, on it. So in terms of difference, if you say, oh, okay, what is the difference between the BLE, the XIAO BLE and the XIAO BLE Sense, is because the XIAO BLE Sense has onboard this, onboard sensors. Then in terms of interfaces, all right, they pretty much have almost the same thing: I2C, UART, SPI, and IS2. I think all of the exception of the ESP32 version has the I2S. All right. Yeah, pulse width modulator and analog pins, looks like they all have 11 PWM pins, and then the ESP32 has smaller analog pins compared to the others, right? The XIAO on its own has 11 out of 11. It's using the same board. Onboard buttons, reset boot, reset button. Onboard LEDs, I think most of them have 3-in-1, and then the ESP32 just has a charge LED. Okay, and then now let's take a look at the programming side of things. As you can see, so the other difference here is that the ESP32 only uses the Arduino C. The rest are all Arduino and then Circuit Python, which is from Adafruit. And then this one has, and then the other three, which is the XIAO BLE Sense, and I think the the N20 something, all can do Arduino, Circuit Python, and MicroPython. So that is why these, at least the last two, are capable of running TinyML. All right. So you're seeing the differences. You can run TinyML on the ESP32 version, right? But you can do that on the XIAO BLE and the XIAO BLE Sense. All right. Yeah. So we've seen the pinout, which I shared with you earlier. I've shared this with you as well. And then the same way, right? We've connected to it. And like I mentioned, you will need to make sure to install the libraries, the ESP32 libraries. Okay. So let's go ahead and now do this. So let's get rid of this. Arduino is already opened. All right. Looks like we're on the same pin. Okay, I've removed it, so that's fine. So in order to add the ESP32 board to it, we need to make sure we have that. So I'm going to copy the URL that you just saw, and then we go to Arduino. Let's go to File. Let's go to Preferences. We have like 6. I think we can do this. Preferences, and then additional board controllers. When you open this was very small the other time, but I'm going to try to make this a bit bigger for you guys. So this is how it looks like. Okay. There you go. Let's do this. Yeah. So as you can see, master Arduino index, expressive if. I don't think I have the expressive if version here. So this one was for the XIAO boards. Okay, Arduino boards, which we've seen. So I'm going to go ahead and add the ESP32 expressive boards here. So I've already copied it. Add it to a new line. So let's go back here and see. Yeah. Okay, there you go. So as you can see, I just added it. Expressive Arduino, so ESP32, GH pages, blah, blah, blah. So now I know where to pull some of this libraries from, right? So I've set this. Click on OK. And then OK here. All right. So now we've added that. Then if you go to Tools, all right, go to Tools, and then you go to, where's our board? Yes, Board Managers. And then it's loading. Okay. Let's wait for it to load. So here, so this is going to load up. And then once it's done, we will type ESP32 here and then download the modules for ESP32. I think I've already done this, but for for the sake of how it's done, let's walk through this again. Yeah. So let's do this. Now remember that the XIAO ESP32 doesn't have an LED indicator, right? Doesn't have one that you can easily blink. It only has a charge indicator. So the LED on it cannot be used for. So if you want to do the basic blink example, you would have to connect an LED with a resistor to one of the pins and then do the LED example. But we will try to do the same temperature humidity example on this one. So here you type ESP32, and then you see, like I said, ESP32, as you can see, expressive systems. So this one is installed version 1 point something installed. This one, it says version 2. Let's see which version is here. So yeah, I think there's a latest version 2.04. So let me update it. Okay, so I already have it, so I'm just going to hit update, and it's going to go to that repository and then update the version of this board manager for me. Now, once this is done, we need to make sure we're selecting the right board and then the right port, just like we've done in subsequent events. Don't worry, I don't think we've done. Yeah, so we have 8 more minutes because we started a bit late, but we have 8 more minutes to go. So just bear with me, right? Yeah, so again, we won't do the blink. Yeah. And if you want to, I think there are processes if you want to, how do you call it? Read stuff and do all the crazy things you can. But for the sakes of this, we will not. I think it's installing. Okay, so yeah. And sometimes there's been reported issues where the board is not showing even after you do that. You might want to re-flash it with the firmware from Expressive If, and we can go to that page actually. There's a utility they have that you can use to do that. So if you go to Expressive If, I'll show you. Let's wait for this to be done, and then I'll show you how that is done. Okay, well, okay, whilst that's happening, let me bring this here. So if you go to the Expressive If, let me actually copy this. I'll add it to the show notes. So if you go here, right, and then you have support and you come down here, you should see we have a certificate and test. So you see the ESP RF test tool and test guide, right? So you can download this test tool, and then you can also have the flash download tools, which you can. So if you need any of these tools to further process, you can just go ahead. So yeah, we'll just go ahead and download the test. Actually, let me select this and that, and let's download this. No, that's gonna eat into our bandwidth. Okay. I'll just put it in download. I hope it's not huge. Okay, let's drop it in downloads. Hopefully, oh yeah, there we go. Well, it's not that bad. I mean, if you're streaming and you're still pulling data from the internet, yeah. And like you said, I mean, this is not pre-recorded, so we get to see it as it happens in real life. All right, I'm just going to close this. Thank you for service. We have 2 more. We have 2 more tools to be downloaded and direct. So I think we have 5 more minutes. Yeah, I mean, it's quite straightforward once this happens. So hopefully the goals of the demo days will be kind to us. All right, so what to expect? Let me just start laying this out. What to expect? So now we've unwrapped all the XIAO modules. Now, unique to each of them, from the ESP32, which is an ESP32, MCU, to the BLE and BLE Sense. So unique things for the ESP32 would have the Wi-Fi. So the next thing will be to see how do I set up Wi-Fi on it so it can communicate and maybe send it to Quibutro and IoT Hub or IoT Central. So that would be an episode coming, and then the second part would be how do I leverage the Bluetooth module on the XIAO BLE and XIAO BLE Sense. So expect 2 more sessions, one touching on how to use the Wi-Fi module and one touching on how to use the Bluetooth module. And at the end of the day, the concept would be, can I have 2 BLE devices and then that can communicate amongst them, sending data. So one would have data and then one can communicate with, let's say, my phone or something. Because you might create applications that need access to the internet and might not necessarily directly have internet connectivity. Because that would be an example. Someone will say, well, what if I don't have the XIAO ESP32C3, but then I have the XIAO BLE or XIAO BLE Sense, right? Good thing. Your XIAO BLE can communicate with your phone via Bluetooth. And since your phone almost always might have data plan, you can create a simple application that leverages the internet on your phone. So when your XIAO BLE or BLE Sense sends data or some information from a sensor, then you can use the companion app on your phone to push that data to your cloud or wherever you're aggregating your data. All right. So that is one scenario. So those are the scenarios we'll be looking at in the future and how to make that work. And yeah, if that sounds like something that is going to be of interest to you, we can do that. We have 3 minutes. 3 minutes. Please help us get to 1,000 subscribers before the month end. If you've not subscribed, it's here by the microphone. This one. Hit subscribe, press the notification bell, and then when we release videos, you get it. And don't forget, I shared the link if you want to join the AIoT user group, Accra user group. Please fill out the Google Forms. I'll try to bring that back again. There you go. So forms, GLE. So this right here, go to that form, fill it out. I want to join the group. These are my preferences or my interests. We'll put you in the right groups and then we'll have some fun. All right. So let's get back to this. Looks like it's done. So we can wrap up for the night. So the installation is completed. Okay. So now with that done, what you now want to do is that you go to tools, you go to your board, and then we can do the ESP32 Arduino, and then we can go all the way down and we can see, go all the way down. Where is it? The XIAO, there you go. The XIAO ESP32 here. See that? So now, this is now in the list. Okay. So just make sure, so you go to tools, your board, the ESP32 Arduino, the XIAO board. I select this. Did I select it? I think I select. Oh yes, I think it's selected. Yeah, there you go. And then to make sure that I am on the right COM port, I'm going to device manager just to be sure. So now let's go to the bench. Awesome. I just connected it. So now you can see it's there. Let's go to our COM port and see. Now you see, so now this is on COM port 12. It's on COM port 12. So we're going to go to tools, we're going to go to port, and I'm going to select port 12. So now if you look down here, where is that? Yeah. Oh, no. Yeah, okay. It wants me to go down. Anyway, if you look down here, right, let me bring you to the screen. So now if you look down here, you see XIAO ESP on COM port 12. Okay, cool. So now that we know this on COM port 12, let's go ahead and then deploy. Select this. Hopefully it should build and put it on our on this one. Okay. And when that happens, we can now go ahead and open the serial monitor, and then we can see it now sending temperature and humidity data to the board. And in a next episode to come, I'll now show how to take this data, use the Wi-Fi module on the ESP32, on the XIAO ESP32C3, and send it to Azure IoT Hub, Cubitro, and then IoT Central. All right. So let's do the 4-way screen, so we can see here it is compiling. Okay, there you go. Go. Writing. Boom, it's done. All right. So it's done. Where's the reset button? Press it. There you go. All right. pressed it. Did I? Yes, I pressed it. Okay, so now let's go ahead and do tools, serial monitor. Oh no! Oh no! Let's try. Let's do this. Okay. Okay. Actually, let me. Yeah. Let's reboot this again. Okay. I'm going to take this out and then reconnect this. All right. And I'm sure I might have to change the baud rate. And here we're just running directly on it without making any changes. Let me show we are on the same. Okay, we're still on port 12. Let's go ahead and tools. Okay. Okay, so interesting. I guess we have to do some small tweaks to this, but it's not able to read it. But yes, well, that's what time is going to allow us to do. But trust me, it will be fixed and it will be shared. If this sounds like something you want to see fixed in the next episode, make sure you go subscribe, like, and then come back next week and let's fix this. Being yours truly, Samuel Adjani, bringing you the awesome and interesting, simple life of IoT to you this and every Tuesday. Stay safe, be good. Let's make the world a better place. And have fun. I'm out.